Welcome back. We are learning about the Thevenin theorems and we are analyzing the circuits with the independent current and voltage sources. So let's have a look at this example now. We have a voltage source 6 volt, we have a current source which is 2 milliampere, and we have to calculate the output voltage V naught, okay, which is basically across the 6 kilo ohm, and we need to use the Thevenin theorem. Okay, so let's do the first step. Take out our load, which is basically 6 kilo ohm, and place it outside of the circuit. So we want to calculate the V out here. The next we need what? We need to find what is R Thevenin. We need to find what is the open circuit voltage or V Thevenin. Okay, let's redraw the circuit. So if we redraw the circuit will look like this one, right? 2K, and here we have 4K. This is 6 volt. This is my current source here, which is basically 2 milliampere, and I have this 2 kilo ohm here, and here basically become our open circuit. Okay, so we need to find what is the R Thevenin from this end and what is the voltage drop between these two nodes, which is basically V Thevenin. Okay, so to get the R Thevenin we need to remove the sources. Okay, so let's redraw the circuit here for the R Thevenin case. Okay, so voltage source, it will become short circuit. Okay, so what I have here, I have this 4 kilo ohm, and then I have this 2 kilo ohm. This current source, it will become open circuit, and we have this 2K here, and we want to find out what is the resistance if we look from this end of the circuit, or Thevenin. All right, so remember, always voltage source, it will be short circuit, always current, always open circuit. Now if you look from the end of the circuit, what we can see here? Okay, so we can easily see that basically this 2K and this 4K, they are in parallel, right? This 2K and 4K. So 2K parallel with 4K. Okay, so this will be equal to what? Basically 8 over 6 or 4 over 3K, right? Now this 4 over 3K, if I draw that, and now this is an open circuit branch, so we can basically remove that. So here we have basically 4 over 3K, and then I have this 2K, okay, this one, and we want to calculate R Thevenin from this end. So now these two are in basically series. So 4 over 3 plus 2. Okay, so what will be the answer? 3 times 2, 6. Okay, 6 plus 4, 10. 10 over 3 kilo. So this is my R Thevenin. So we will put that value here. R Thevenin is basically 10 over 3 kilo ohm. Okay. Now let's come back to our original circuit here. So again, I'm doing this as a third step. You can do this as a second step also. Like we can calculate the V Thevenin first here, and then we move to the R Thevenin. Now to get the V Thevenin here, what we have to do, simply we need to analyze this circuit. So again, you can use different analysis techniques, whichever you have, like we have learned earlier on. Source transformation, voltage, nodal analysis, mesh analysis. Okay, the target is to find what is a voltage drop between these two nodes. Actually, that is a voltage drop across 4 kilo ohm and 2 kilo ohm, because like this whole branch is in parallel, right, with this one. Okay, so if we can find basically the voltage drop across these two, we can get that. So if you look at this circuit, we notice that we have a current source and a voltage source. So it means my target is to find basically what is the current flowing through 4 kilo ohm and what is the current flowing through 2 kilo ohm. So we can use simple mesh analysis here, or loop analysis. So this is the current source independent. So let's say the current through this loop is I1 and the current through this loop is I2. So I1 we can get it directly. So what is I1? That will be 2 milliampere, right? Now to get I2, we can write the loop equation here. So that will be minus 6 plus 4 times of I2 plus 2 times of I2 minus I1, right? So I2 minus I1 is basically 2 is equal to 0. Let's just simplify this. So minus 6 plus 4 times of I2, 2 times of I2 minus 4 is equal to 0. So 4 and 2, 6. So 6 times of I2 minus 6 minus 4 minus 10. So that will be equal to 10, or I2 will be basically 10 over 6 or 5 over 3, right? Milliampere. Okay, so once we know I2, once we know I1, we know that Thevenin is just nothing. This is a voltage drop, okay, across 4K and 2K, right? So we can write that Thevenin is basically voltage drop across 4K times what is the current flowing through 4K, I2. What is I2? 5 over 3, right? Milli. Plus voltage drop across 2K, that will be 2 times what is the current going through this one? 2 milli, okay? So 2K times 2 milli. Okay, so if we simplify this one, this open circuit voltage or Thevenin voltage, it comes out to be 32 over 3 volt. Okay, so we have our open circuit voltage here. Now we left with the last step. What is the last step? To find the V naught. So simple, we have a simple Thevenin circuit. So V naught will be basically what? Simple voltage divider. This resistor 6 divided by the total resistor 6 plus 10 over 3 multiply with the source voltage. What is the source voltage? 32 over 3, right? So if we just simplify this one, okay, we can get our desired output voltage. Okay, so what will be that value? We can easily get that. So we know that 10 over 3 is 3.3 plus 6. This multiply with 6. Okay, so that comes out to be 48 over 7. Okay, or 6.85 volt. Okay, so this is the output voltage. So this is how we can analyze a simple circuit using the Thevenin theorem. Thank you so much.